Okay guys, so we're here today to learn about how do we differentiate y equals 4 to the x. So what do we do basically if there's an x in the exponent? And we're going to talk about this and then some other exponent rules today. So if you were a chump, you might look at this and be like, well, her to her, why don't I just bring the power down and subtract by 1? But you can't do that if it's an x, only if it's a constant. So I'm going to come up with a formula right now, and then I'll show you what the pattern is basically. So let's try something weird. Before we even do this, let's take the natural log of both sides. So we'll take the natural log of y equals the natural log of 4 to the x. Now, one of the things you might remember is that if we have natural log of a to the b power, you could bring that exponent down in front and write it as b times the natural log of a. So I can do that as x times the natural log of 4. Bring that power down in front. Okay, so then when I take a derivative here, I'm going to use implicit differentiation like we've done in class. So if you take the derivative of both sides, the derivative of ln y is 1 over y times the derivative of y, and then x ln 4. Okay, so if we take the derivative of 3x, that's 3. If you take the derivative of 7x, that's 7. ln of 4 is just a constant like that. So the derivative of ln 4 times x is just ln of 4. So your dy dx is equal to y times ln of 4. And then from here, the only thing you can do is you can just plug in your equation for y. We started with y equal 4 to the x, so the derivative of that is equal to 4 to the x times the natural log of 4. So you can remember this strategy or not, but the key thing is this, is that if you take the derivative of a to the x power, where a is a constant, that is always just going to be a to the x power times the natural log of a. So if I ask you, for instance, what is the derivative of, I don't know, like 10 to the x? Well, the derivative of that is 10 to the x times the natural log of that base, times ln of 10. If you have something a little more complicated, say it's, I don't know, like 10 to the power of sine of x, then you're going to start with your derivative being 10 to the power of sine of x times the natural log of 10. And then by the chain rule, you have to multiply by the derivative of sine of x, so you have to multiply by cosine of x. You know, if I had, for instance, like, I don't know, 5 to the power of x cubed plus 1, well, again, your derivative would start with 5 to the power of x cubed plus 1 times the natural log of 5, and then you multiply by the derivative of that, which in that case would be 3x squared. So that's how you deal with a derivative if you have a constant raised to a power with an x in it. So I wanted to show you that. Okay, from here, I wanted to go ahead and do some review and maybe some new stuff on exponent rules. So here's a question I want to ask. Can e to the x ever equal 0? So basically, is there an x with e to the x equaling 0? Okay. Now pause and think about that for a minute if you want. Anyway, the answer to this question is no. There is never a value. And you can see this, one way to see this graphically. So for example, if you were to graph this function, here's a graph of e to the x, right? It has an asymptote, but it never quite reaches 0, right? It's always like a little above the axis there. So you get this function that is always positive. It's always above the x-axis like that. Okay, so that's how you kind of want to think about this, is that e to the x is always positive. And to generalize that, e to the stuff, whatever's in that exponent, is always positive. And there's nothing special about e, right? This is true for 2 to the x, or 10 to the x, or 20 to the x, any positive number there. Okay, so for example, say I ask you to solve the equation for x, and this is something that's going to come up sometimes, x e to the x squared minus 12e to the x squared equals 0. Now, you might look at this and just kind of think, oh my goodness, what did I get myself into? But then you recognize I can factor something out, right? I can factor on e to the x squared. So I have e to the x squared times x minus 12 equaling 0. Okay, so either e to the x squared equals 0 or x minus 12 equals 0. Well, this never happens, right? This has no solutions. E to a power is never equal to 0. So the only solution to this equation is x equals 12. And we'll see this technique come up a couple times, but in general, just remember that e to a power is always greater than 0, no matter what you have in that exponent. Okay, so that's just like a fancy little thing to remember no matter what we have there. Okay, so that in mind, let's just do some exponent and log review. So here are just some old rules to remind you. If you have x to the a to the b power, like x squared to the third power, you actually end up multiplying those. This is x to the sixth power. This is x to the a times b. You can remember the x is like x squared times x squared times x squared. If you have, say, x to the a times x to the b, like x squared times x cubed, you actually add those. That's x to the fifth, a plus b, or the x to the fifth power. And you can recognize that. That's like just 5x's multiplied together. Okay, if you have, say, x to the a over x to the b, that's x to the a minus b. So we know that, right? If you have like x squared over x to the fourth, that's x to the 2 minus 4, which is x to the negative 2. So those are just some rules on that. Some other things is that if you have, like with logs, the natural log of a to the b power, we saw this earlier, you can bring that down in front. That's b times the natural log of a. If you have the natural log of ab, you can break that into the natural log of a plus the natural log of b. So this might be helpful if you have to deal with like an ln of x times y. It might be useful to write that as ln of x plus ln of y. That's a lot easier to take the derivative or work with of. So if you have like ln of a divided by b, you can write that as the natural log of a minus the natural log of b. Okay, and I wanted to also note, like, if you have like the natural log of a plus b, there's no formula for that. If you have like an addition or subtraction in your log, there's no like simplification on that at all. Okay, and just a couple other simplifying tricks. These are going to help us solve equations, but just to remind yourself that if you have like e to the natural log of a, the e and ln cancel. They're inverses, you get a. If you have the natural log of e to the a, those cancel, you just get a. So ln and e kind of cancel each other out. So for example, if you have to to solve the equation, say, I don't know, e to the x equals 5, what you could do is just take the ln of both sides. So just say, all right, I'm going to go ahead and take the natural log of the left side and the natural log of the right side. So I get x equals the natural log of 5. So same thing, right? If you have, ln of x plus 2 equaling 7, raise e to the power of both sides. So you get x plus 2 equals e to the 7, and then x equals e to the 7 minus 2. This is actually even useful if you have something like this, like solve, say, 4 to the x equals 8. So what you can do is if you have an x in the exponent, you can still go ahead and take the ln of both sides. So you say, I'll take the ln of this, I'll take the ln of this. And then you can bring that down, right? So it's x times ln of 4 equals ln of 8. That's just the first log rule we talked about, bring the power down. And then we can just divide and get x as the natural log of 8 divided by the natural log of 4. Okay, so those are just some reviews, some good things to look at, some properties to remember. Let me know if you have questions. I'll see you guys soon.